I want to dedicate an entire video to misconception question number 1. And the reason is because I think it's a very rich problem that really forces us to understand changes in momentum that happen during a collision and how momentum is conserved during a collision. Okay? So let's take a look at it. We have a truck that's going at 15 kilometers per hour, right? So here's my little truck, and it is going at 15 kilometers per hour in the positive direction, right? And it collides with a small car that is over here that is also moving in this direction, right? And it says it's going at 30 kilometers per hour. And notice it doesn't give us momentum, it just gives us velocities. And so I'm going to say, let's disregard those velocities, okay? Let's instead just pick some random momentums for each of these guys, okay? And we'll see how those momentums need to change in order for momentum to be conserved. All right, so let's start out with this guy having a momentum of 5. We won't even pick any units. We'll just say 5 momentons, whatever, okay? And we'll say that this guy has a momentum of -2 momentons. All right. Now, what do we know? We know that the total momentum of this system, all right, has to add up to, we'll go over here, we'll say total momentum is P1 plus P2, so P total, equals 5 plus a -2 equals 3. Okay? So we know that after the collision, whatever the momentum of the separate individual trucks and car are, they must add to 3. That's what conservation of momentum means. Okay? So let's do a little sample collision. They collide. Okay, and let's say that now, in the after situation, we have the truck moving away with a momentum of -1, and now the car is moving away in the other way with a momentum of, well, what would it have to be? These guys have to add up to 3, correct? Which means if this is -1, this would have to be 4, right? 4 plus -1 equals 3, right? So let's see, what was the change in momentum of each of these two vehicles, all right? Well, here we have change in momentum is 5 minus a -1, which is 6, okay? So the magnitude of the change in his momentum is 6. And the magnitude of this car is, well, let's see over here. We have -2 minus 4, which is -6, but the magnitude would be 6. It changed by 6 again, okay? So delta P magnitude is 6. Okay, so in this case, they have a collision and their momentums both change by 6. All right, well, let's say that there's a different situation. Let's say that this guy actually recoils at -3, right? So after the collision, he's got a momentum of -3 in the negative x direction, okay? And let's say that this car now also recoils, right? What must be the momentum of this car? Well, what do we need to add to -3 in order to get a net momentum of +3? Because it started out with 3, it needs to end with 3, okay? Well, I would say it would have to be 6, right? Because 6 plus -3 is 3. So that would be momentum being conserved. Okay, so let's again look at the change in momentum, right? We started out with 5, we end up with -3. So this would be 5 minus a -3, which would be 8, okay? And here, the change in momentum would be -2 minus a -6, which would be -8, or a magnitude of 8, right? So they both change by a magnitude, right? Absolute value of 8. Now, which of these situations here, A through D, is a situation that follows this pattern that we're seeing? That after each of these collisions, the momentum, the magnitude of the change in momentum for the truck must equal the magnitude of the change in momentum for the car, okay? I'll give you guys 3 seconds. So let's go through these one at a time. It says the truck has the greater change in momentum because it has the greater mass. Is that what we're seeing? No, the change in momentum of the truck is the same as the change in momentum of the car. That can't be right. B, the car has the greater change of momentum because it has the greater speed. Can that be true? No. Once again, the change in momentum that we're seeing by the car for each of these collisions is equal to the change in momentum that we're seeing for the truck. C, neither the car nor the truck changed its momentum. No, that's not true. They definitely do have a change in momentum. Here, the change in momentum is 6. Here, the change in momentum is 8. D, they both have the same change in magnitude of momentum because momentum is conserved. Yes, that has to be true. Okay? If momentum is going to be conserved, right, then if the truck's momentum changes by 6, the car's momentum must change by a corresponding amount, right, so that it evens out, right? It'll be, different signs, but the magnitude of the change has to be the same so that momentum is ultimately conserved. Okay? So this is one way to explore and one way to look at this idea of conservation of momentum.